Explain this question in this video lectures. We have a body in simple harmonic motion oscillates with a frequency of 10 Hz and an amplitude of 5 centimeters. We have to calculate the acceleration at the center of oscillation, the acceleration at the end of oscillation, the velocity of the body at the center, both at the center and at the end of oscillation. And also we have to calculate the velocity of the body at 2 centimeters from the center of oscillation. So before we start, one thing you need to notice here is that at the center of oscillation, the displacement of the body is zero. And a very important point to note here, this will aid us in our calculation. And at the end of oscillation, the displacement of the body is equal to its amplitude. Usually I use this letter x naught for my amplitude, or I can use this uppercase letter A to denote the amplitude of oscillation. So very important, at the center of oscillation, the displacement is zero. The center is also called the mean position or the equilibrium position of the body. And at the end of oscillation, the displacement equals the amplitude of oscillation. And here we're given the amplitude as 5 centimeters. Is given in the question with an amplitude of 5 cm. Look at it here. And the frequency of 10 Hz. Here we're to calculate the acceleration at the center of oscillation. And what's the expression for acceleration? A, that is omega squared x. Okay, so since x is 0, it means that at the center, okay, that's the first question. I call that 1. A is equal to 0. That is, the body has no acceleration. It has a 0 acceleration. And when the acceleration is 0, what does it tell you about the speed? That the speed of the body will be constant and maximum. It's going to be constant and maximum, which I showed that later at the center of oscillation. Then at the end, the II part of the question says, what is the acceleration of this body at the end? At the end of oscillation, we know that the displacement equals the amplitude. So we're going to write A is equal to minus omega squared times x. And I will have to find my angular frequency first. Angular frequency is 2 pi. I'm going to take pi as 22/7. 2 pi times f, and so that this gives me 2 times 22/7 multiplied by 10. We'll give the frequency as 10 Hz. So that gives me 2 times 22, 44. That is 440 divided by 7. Okay, I think I have my calculator here very quickly. So we can compute the evaluate that 440 divided by 7 gives me 62.85. Okay, so the angular frequency is 62.86 radian per second. So with that, I can find the acceleration at the end of oscillation. That is A equals, if I want to find the magnitude, we can ignore negative sign. Negative sign here can indicate the direction. And then sometimes they use negative sign as the minimum acceleration if negative sign is attached, because you have a situation whereby the acceleration can be a positive or it can be a negative. But if it asks for the magnitude of the acceleration, we ignore the sign. So that gives me 62.86 squared multiplied by the displacement, that is amplitude 0.05. So I'm going to square that result quickly. That is this squared, give me this, multiplied by 0.05. So confirm there for me. I'm having 197 here, 197.5 meters per second square. So that gives the acceleration at the end of oscillation. So the next question says we also calculate the velocity of this body at the center of oscillation. I already said at the center of oscillation, the displacement is 0. Now, what is the velocity equation? In my other video, I wrote it down as omega square root of my amplitude squared. Let me use letter A for amplitude minus displacement squared. So at the center, my x is equal to 0. So I have V equals, I already found my angular frequency at 62.86 multiplied by the square root of, what is that again? 0.05 squared, because my amplitude was given as 0.05. Okay, the square of the square root of that will give me 62.86 multiplied by 0.05. Okay, so let me use my calculator again. 62.86 times 0.05. That will give me 3.1 approximately meters per second. So that gives the velocity of the body, and it is maximum. Recall I said that when this body oscillates between the two extreme points A and B on the other side of the center of oscillation, that the velocity is peak, is maximum at the center of oscillation. And at the same center of oscillation, we have seen that the acceleration of the body is zero. Remember that when the body accelerates, it should be moving with increasing velocity. So when the acceleration is zero, which means that the velocity will stop increasing, it has reached its maximum. So zero acceleration means that velocity has stopped increasing, meaning that it has reached a maximum. So that's why the velocity is maximum at the center of oscillation, and that gives us 3.1 meters per second. Okay, quickly we want to look at the velocity again at the end of oscillation. Let me move my sheet to this side. Now, at the end of oscillation, my displacement is equal to my amplitude x naught, which was given to us as 0.05 in meters. All right, so that quickly my v equals omega square root of amplitude squared minus displacement squared. All right, so since that is the case, I have here omega multiplied by this is 0.05 squared minus 0.05 squared. Or I can just replace this with a squared because the displacement is equal to a squared or x naught. You can remember I said you can use a for amplitude or just x naught for amplitude. So it is very clear here that the velocity of the body at the end of oscillation is equal to zero. So if I use the case of a simple pendulum to make my illustration, let's say this is where the bulb is at its rest position and it can swing to one extreme end here, point A for instance, before it returns back to point O, and also can swing to this extreme position, point B. Okay, so which means the bulb is free to swing between these two ends. So this point is what we call the end of oscillation. The velocity of the body becomes zero. If the velocity is not zero, it means this bulb should continue like this past point A. That's what makes it return to point O, and that's what makes the motion of this body to be what? Oscillatory, simple harmonic, because it must keep coming back to the center of oscillation. All right, so that's what it means. Then, of course, at this same end of oscillation, we know that the acceleration is maximum. This is where we have the maximum acceleration, omega squared multiplied by the amplitude x naught or a. So you can see that where the acceleration is maximum, meaning that the acceleration has reached its peak, velocity will become zero because we get our acceleration by differentiating velocity with respect to time. So a maximum value of acceleration gives a zero velocity. All right, so I think that is the question. The last question here says we should find the velocity of the body 2 centimeters. You can see that here from the center of oscillation. In that case, my displacement is 2 cm, and then the amplitude, let me use A or x naught. Okay, let me use A, remains 5 centimeters. I'm going to express these two values in the SI unit, standard unit. This gives you 0.02 meters and my amplitude is 0.05 meters, so that my velocity v equals omega square root of what? A squared minus displacement squared. So I have this as 62.86 found out before into this is my amplitude, which gives me 0.05 all squared minus 0.02 all squared. Okay, that is my velocity. So I need a calculator here quickly to evaluate this. That gives me 62.86 square root. If I take the square root of 0.05 squared, that gives me 0.05 squared, 25 exponents minus 3. We can change that to standard form. Minus I have 0.02 squared. That gives me, that is 4 exponents minus 4. Okay, minus 4. I can also express this in standard form. Okay, that was 2.5, sorry, not 25. So that gives me 62.86 multiplied by this 2.5, that this gives me 2.5 minus 3 minus, if I take this to the power of minus 3, that will give me 0.4 times 10 to the power minus 3. Okay, so 2.5 minus 0.5 minus 0.4 gives me 2.1. So 2.1 is my minus 3. I'll take the square root of that, multiply that by 62.86. That gives me the velocity at that point. So if I take the square root of 2.1 exponent minus 3, that gives me 0.045 multiplied by 62.8, 2.86. That will give my answer as 2.88. So the velocity is 2.88 meters per second. And let's compare that with the result we got before for our maximum velocity. Recall that our maximum velocity was 3.1. So we can see that it's actually maximum because the velocity of the body at a displacement of 2 centimeters from the center of oscillation is 2.88, which is less than the maximum velocity of the body. Okay, so in the next video, we will continue with our discussion on the simple harmonic motion. Thank you.